Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. Okay. The name behind the channel is Richard, and I'm just here to see what we can do with this one. Okay, we are having this case. It says consider the hypothetical equation shown. This is it. A plus B giving you C. The rate versus time graph below represents changes which take place on the equilibrium above. This is the graph we are having, and something comes up. They say that temperature was decreased. Okay, at T1. So this happens to be our T1. Okay. So the first question says, predict whether the reaction is endothermic or exothermic. So how do we deal with this? Okay, let us look at here. Let us rewrite the equation. It is A plus B giving you C. We don't know. We don't have the enthalpy change. We are supposed to get it from here. Now, when you look at our graph here, let us analyze this area. What do we see? Two things are supposed to be, two informations is supposed to be provided by this change. One, rate is decreasing. Okay. Two, remember, look at here. The solid one represents the forward direction. So forward is favored. Okay, we need to know that whatever is on top here is the one which is favored. So in this case, when temperature was decreased, forward was favored. So what do? You go to our equation. This is our forward. And our forward is favored by decrease in what? In temperature. And then you go and consult theory. In theory, we say that decrease in temperature favors exothermic reaction, while increase in temperature favors endothermic. So if temperature decreased on this reaction and the forward is favored, so it means that forward is exothermic. So our enthalpy change is going to be less than 0, meaning exothermic. Thank you. That's one question. Let us go to the next one. Then comes this question. It says, state what happens to the yield. So when the question talks about yield, it means the amount of product formed. So the question can be rephrased, state what happens to the amount of product formed. Does it increase or decreases? So what do you do? Okay, let us have the equation again. It's A plus B giving you C. And what have we just realized? We realized that a forward is favored from the previous question. So if forward is favored, what happens to our product? Forward favored means that the reactants are decreasing to form the product. So the answer is increase. So the yield will increase. Okay, that is answered. Let's look at the next question. There comes another question. It says that state what happens to the activation energy of the reaction. Okay, here you need to borrow your theory. We know, or we should know, that activation energy is independent of the temperature. It does not depend on the temperature. So what is the answer? The answer is remains the same. Okay. Let's go to another question. Then comes this question. Remember, we are talking about temperature decrease. This is what the question says. State what happens to the equilibrium constant Kc. What happens to the value of the equilibrium constant? So when you look at this equation, this is what we predicted already. We know that A plus B gives you C. And we found that enthalpy change is less than 0. The reaction is exothermic. So knowing that the reaction is exothermic, can give us an insight into the change in equilibrium constant. This is what we must know, that for exothermic, an increase in temperature decreases Kc. That's according to Le Chatelier. And a decrease in temperature increases Kc. That's exothermic. Okay, briefly let's talk about endothermic. For endothermic, increase in temperature increases Kc. And a decrease in temperature decreases Kc. So this reaction being an exothermic and temperature decreased, what happens to the Kc? The Kc will increase. Okay, that one is answered. Okay, then comes another question here. It says, state what happens to the enthalpy change. So what happens to the enthalpy change when temperature decreases? Now you need to know that enthalpy change is a characteristic of the equation, of the reaction, and it is independent of the temperature. So what's going to be the answer? The answer is it remains the same. It is independent of changes in temperature. Okay, let's see what comes next. Then comes this question. The question says, redraw the graph in your answer book and indicate the changes which take place when pressure at T2 is increased, or when the pressure is increased at T2. Okay, this is the scenario. We are having our T2 here, and we are supposed to draw the changes which occurs when pressure is increased. So how do we answer this one? This is what we do. We have the equation. The equation is A plus B giving you C. And in predicting pressure, what do? Oh, we have to remember that all of them are in gaseous phase. So in predicting pressure, what do? You do the count. How many moles of the reactant do you have? They are 2. So you come this side and you count the number of moles of the product. They are 1. Okay. First of all, now we are going to first predict the rate. What do you mean by predicting the rate? We are going to find out whether we are going to shift upwards or downwards. So remember, this is rate. So you have to go and visit rate. There are 6 factors which affect the rate of reaction, and pressure happens to be one of them. So when you increase pressure, what happens to the rate? The rate increases. So that means that we are going to shift to our upwards. So that one is already predicted. We are going to shift upwards. The rate is going to increase. Now, next part, we are going to predict which direction is favored. Is it forward or reverse? So there you have to visit the theory. The theory says, according to Lechateria, that increase in pressure favors the change from high number of moles to lower number of moles, and decrease in pressure favors the change from lower number of moles to high number of moles. So what are we having here? We are increasing pressure, and increasing pressure is favoring that direction, which is forward. So forward is going to be favored. So 2 things now have been identified in this case. Rate has increased and forward is favored. How do we show that on the graph? You shift upwards, but with the one favored on the top, then the one which is not favored comes and follows like that. So this is it. These are the changes you're supposed to show. This one indicates that rate has increased because we have shifted upwards, and it also indicates that forward is favored. That one is answered, so let's go to the next question. Then comes this closing question of this video. It says, draw the concentration versus time graph and indicate the changes at T0, T1, and T2. So how do we do that? Let us see what we can do here. So this is what we have. We have the axis, and we start. So the question wants us to draw concentration versus time graph and indicate the changes which took place at T0, T1, and T2. So from the graph, what do we see? From the T0, we see that the reaction is just starting. When the reaction is just starting, this is what we have to know, that our product at the start is 0. So it comes like that. Why is 0? The reaction is just starting. All you have are the reactants. So at the start of the reaction, products are 0. That's why the starting point is 0. So for these two, they are the reactants, so they can come from anywhere. This question actually is to impart some information to you, which you will need, because you need to be armed with this information to answer the questions which are going to come your way. So we want you to take this one very seriously. So what do we do? Now T0 has been represented and we are done with it. Let's go to T1. What happens at T1? Temperature decreased. Okay. So when temperature decreases, what do we know? We have to know that this reaction, it is exothermic. That one is, we know. So in exothermic, what do we know? When temperature decreases, the decrease in temperature favors forward, because the forward reaction is exothermic and the decrease in temperature favors exothermic. So this is going to be our direction. And what does this mean? That this one is going to decrease. Okay. And this one is going to increase. And we are supposed to show them here. So on assumption, okay, this one is clear. This one is C. So if this is our A and this is our B, so from the prediction, what happens to our C? C increases and it's a gradual increase. It's not a spike. Okay. What happens to our B? B decreases and it's a gradual decrease. It's not a spike. And the A decreases. These ones I've just obtained them from those changes I've predicted there. So I'm done with the T1 and I'm heading for T2. So this is our T2. What happens at T2? We said pressure increased. Okay. When you increase in pressure, what happens? Something happens here. And I want us to be very keen here. When you increase pressure, you increase the concentration of all first. So all of them first spike upwards. Okay. This one spike upwards, this one spike upwards, this one spike upwards. That's what they do before they settle where they are supposed to settle. So after that spike, what happens? Okay. What happens is this one, let us use this space, A plus B giving you C. It's very important that whenever you're predicting this one, you write the equation. So increase in pressure favors forward direction. And forward means that A is decreasing and B is decreasing to form what? C. Remember, increase in pressure favors the change from high number of moles to lower number of moles. So if these are 2 and this is 1, so that's the direction. It's forward. And forward means what? I repeat. Forward means that A and B are decreasing. So they come down like this. And it means that C is increasing. We don't mind crossing there, provided we can trace its origin. So literally, this is what happens. The crossing is not what is being examined here, but the changes. What we have noted here is that A and B have dropped below their initial level, and C has what? Increased. That's what happens at T0, at T2. So this is the graph which was wanted, and we thank you for being with us. We urge you to subscribe. It's very important that you do so. See you in the next video. The channel is PSSB, Physical Sciences Silver Bullet, and the name behind the channel is Richard. See you next time. Bye.